So f parentheses x, though, it does not mean f times x, okay? If I were to write this, and I'm going to put this in quotes, what this means is, if I were to say this, is f of x, and you're going to hear me say that. F of x equals, f of x equals, f of x equals. This does not mean I'm going to write f times x. Okay, and what we're going to do is, in an equation, when we have a y equals, we're going to instead use f of x equals. So it is going to replace y in an equation. So really, f of x on a graph is the same thing as the y. If you think of the vertical axis, the function is being graphed on the y-axis. Okay, so what do we say for a function rule? If I say write a function rule, this is really just writing an equation. And we've done a little bit of practice with word problems with that already, writing an equation. And so the way that we're going to write an equation, sometimes we would write it before as y equals. Well, today we're going to write it as f of x equals something. Okay. So let's talk about, let's say I wanted my function rule to multiply something by 2 and then add 1. Let's say my function rule was I'm going to multiply something by 2 and then add 1. How could I write that with an x? We practiced writing those with n last unit. 2x plus, I said 1, but you got it. Yeah, 2x plus 1. I want to multiply something by 2 and then add 1. If I was, I'll say multiply a number by 2, then add 1. If I said write a function rule for that, we would write f of x equals 2x plus 1. F of x equals 2x plus 1. Now here's the cool thing about function notation. Do you remember how I had to have you make a table before and I had to write input? If I want to tell you what to input, I can put it right in the spot where the x is. If I wanted you to figure out what it was for 1, I would write find f of 1, and that would tell you, oh, instead of x I'm going to put a 1. And so that's what we're going to work with. So yesterday I talked a little bit about domains. You guys remember what I said? Good. So the domain are x values. Very nice. Anything else? You can cheat and look back if you want. It's the same thing as the independent variable. There's another I word that I used. Anybody remember? Good. Input. It's what I'm putting into my function rule. It's what I'm putting into my function rule. It's the things I'm going to put in for x. Okay. So, the range are y values. But now I'm calling, we said y is now going to be what for a function? What's going to replace our y in the equation? F. Tell me that. F of x. Okay. So y values, or f of x values, good, output, and the dependent variable. Okay. So if I ask you to evaluate a function, what I'm going to tell you is I want you to find, it's going to be finding output for specific input. Finding outputs for specific input. Do you know what the word specific means? Yeah. So like this is in general, 2 times a number plus 1. If I wanted you to find a specific one, I would say, hey, what would that mean when x is 5? That would be a specific x value, okay? So when I say specific, I mean I'm going to put a certain one in, and I'm going to get something else out. So, be careful, because we have to make sure we observe order of operations when we do this, okay? So, let's take a look at an example, and if we have to do more, we can do more. Well, you know what, I'll use this one. Let's use this one first for us with a specific. So f of x equals 2x plus 1. If I asked you to evaluate the function, let's do f parentheses negative 3. Okay. What that means, so you see where my finger is now that that's an x. I want you to take out the x and replace it with negative 3. So here, I'm not going to do 2 times x plus 1. I'm going to do 2 times negative 3 plus 1. And that's what I mean. Now we have to remember order of operations. So we should do 2 times negative 3, which is what? Negative 6. Negative 6 plus 1 is negative 5. So I input negative 3, and it outputted negative 5. Okay. Let's try the next one. I said find f of negative 5 when f of x is 3x squared. Okay. All I'm telling you to do now is we're going to evaluate this when x is negative 5. So I'm going to write f of negative 5. So this is 3 times x squared. What should I write? Siley? Good, and would you do a favor for me? Make sure you put that negative 5 in a parenthesis, because we're squaring the whole thing negative 5. Okay. In our heads, let's square negative 5. What is that?
25.
25. So I'm going to do 3 times 25. Okay, and so notice how I did an order of operations. I did the exponents first. Okay, well what if I give you wacky stuff like this? Don't make it a big deal. It doesn't have to be a number. This function says f of n equals n minus 3. So if I ask, what is f of 2x, here's all that means. Do you see how this was an n? Now, and you see there's an n right here. Well, I want you to take out the n, and what do I want you to put in its spot? Not x, but look, what's this whole thing? The whole thing 2x. Okay, so I am going to take out the n, and in its spot, I am going to put the 2x. Isn't that what I did up here? I took out the x and put a negative 3. You can swap out any variables you want and put other variables in. So I could write then 2x minus 3. Where the n was, I put that. Okay. Hey, We even use this in like pre-calculus and AP calculus. I'll do things like this. I'll say, hey, there's this function, x squared plus 3x. Uh-oh, I'm running out of ink. You don't have to write this down, guys. Just watch, okay? And then I'll say, hey, can you take out x and replace it with 2x? And they'll be like, what? And I'm like, just do the same thing. Here I was squaring x. So what should I do to 2x? Square the whole thing. Here I was doing 3 times x. Here I should do 3 times 2x. Okay, I'm not asking you to do that right now in algebra, but what I'm saying is that this really can work for anything you want to swap out. This is a rule. This means square something and then multiply it by 3. I can square anything I want in that parentheses and multiply it by 3. Okay. That's one way we're going to do this with equations. Next thing we should practice. This is called an absolute value. Have you heard of these before? Okay. Absolute value is really something that describes distance from 0 on the number line. We're going to get into that more later. Sometimes I can use the graph to find f of 3. Okay, so I want to find f of 3. So what I do is I'm going to go, this is what x is, correct? Okay, so I'm going to go over to 3 on the graph. Put your pencil there. Remember the f of x values are which values? The y values. Okay, so let's go up to the graph. And wouldn't this ordered pair be 3, 1? What's the y value? 1. So what does f of 3 equal? 1. Okay. Hey, I'm going to have you try another one. Let's see if you can figure this one out. On the same graph, can you guys tell me what does f of 2 equal? Yep, what does f of 2 equal? Go on the graph and see if you can figure it out. Put your finger on the graph when x equals 2. What do you think, Caitlin? Good! Here's 2. Hey, it's right on, isn't this the point 2, 0? So what's the y value when x equals 2? It's 0. Okay. This is asking the opposite direction. I said find 2 values of x so that f of x equals 2. I'm telling you, hey, when the y is 2, what's the x on the graph? Let's look. So I'm going to go up to 2. This is the y-axis, agreed? Yep. I am going to go up to 2 on the graph and see where the v hits. I see that it's here and here. Are you seeing that with me? This is the point -4, 2, and this is the point 4, 2. Do you see on both of them that their y value is 2? My question is, what are the x values? One of them would be -4, and what's the other one? Very nice. Good. Last thing, guys. Actually, I think this is the easiest of all of them. Rewrite using function notation. Well, maybe you won't think so. I don't know. This is just fancy notation, okay? So when you see a y, we are going to replace it with f of x. So here's how we're going to do this one. Instead of y equals 3x minus 2, f of x equals 3x minus 2. Okay. Now, here's the other thing. Function notation doesn't have to be f. F is like our most basic one, f for function. But we can make it stand for whatever we want. This is an area formula. Have you guys ever found areas of circles earlier on? Okay. So what is the area based on? The what of the circle? The radius. So this is how I would write this in function notation. The area of r, of radius r, is equal to 4 pi r squared. That way I know that my function is talking about A, area, with respect to the R, radius. Do you guys recognize this formula from science class? What is it? It relates temperature for Fahrenheit and Celsius, and here's what it's saying. To find its Fahrenheit, you take 9/5 times its Celsius temperature and then add 32. So, would you agree I'm finding the Fahrenheit temperature based on the Celsius temperature? So I would write F of C equals 9/5 C plus 32.